Hey Science 10, welcome to another lesson for physics. I'd just like to do a few housekeeping things in this video here before we get too far. All the formulas that we're going to be using for physics are in your data booklet, and this is a big hint here. It's in your data booklet. Does it say what page it is? Page 2 it says here. Okay, so these are your formulas right here. Okay, this whole list is your formula. Okay, so we have kinetic energy, potential energy, force, a whole bunch of things like that. Here's your thing for speed, okay, and here's your things for velocity. You can see that they're exactly the same, but I recommended that you change this V to S just to keep it changed in your head. So the cool thing about this, it shows you your formulas, and if we were in a normal class, you could use these formula booklets for all assessments, so and even for your final exam. So that's good to have this with you at all times. Another thing that's cool about this is this list over on this side. Okay, on this side it shows you what each letter or symbol in the equation represents. So if you look over here straight across from V, it tells you what average speed is. It tells you what average velocity is. Okay, and then it tells you the letters that are in the equation, D, and D with an arrow over its displacement. Okay, another big thing to note from this is these things here. So it tells you what unit they're supposed to be going in. So your final answer should always be written in these units. Okay, so you don't know what a Newton is yet, but you will. Okay, so you must write your answers in these forms, okay, for these types of questions. So that's another little hint for you. Okay, so we're going to move on now to our lesson on uniform acceleration. Okay, and you'll notice, like I said before, meters per second squared is the unit that we are going to be using for this, okay? So, oh, that's not right. Okay, we're going to start right here. Okay, when the speed changes, we're no longer talking about uniform velocity or constant velocity. If the velocity of an object changes during a time interval, this is what physicists call acceleration. Okay, the change may be an increase or a decrease in velocity, and the change in velocity is a vector quantity. So is acceleration. So these are all considered vectors. Okay, that's why you have these arrows down here in the equation above the letters. Okay, the numerical value of acceleration states how much the velocity is changing in meters per second squared. Okay, remember that. Okay, so this is your formula down here. I already drew an arrow to it down here. Okay, notice its initial velocity is how fast it was going at the start of the time interval, and the final velocity is how fast it's going at the end of the time. So obviously it could go from 100 kilometers an hour, or let's use meters per second. It could go from 100 meters per second down to 80, and it would be a negative acceleration, or you can have it go the opposite from 80 up to 100 and have a positive acceleration. Okay, so it's basically a rate of change of velocity. It is a vector, and a common one that you're always going to need to know. So there's going to be some questions you get that look like you don't have enough information to answer, and it'll be about an object falling. And this is just a uniform piece of information you must always remember pretty much for this point moving forward. So the acceleration due to gravity is 9.81 meters per second squared. Okay, you must always remember that because you're going to get a question and it's going to be about a rock dropping off a roof, or a person jumping off a cliff into a water, things like that. And the acceleration simply by gravity is always 9.81 meters per second squared. So that might be a missing piece of information that you need to solve questions down the line. So this number is not in your data booklet, but it's a very important number to remember, and it's just something you're going to have to memorize, okay, moving forward. Okay? So let's try a practice question here. So this says Space Cadet Robin, 3rd class, so from Star Trek, drops a large rock onto Captain Kirk's foot. The initial velocity was 0, and the rock hit the foot in 0.342 seconds at a final velocity of 8.44 meters per second squared, or 8.44 meters per second. What is the magnitude of the acceleration of gravity on the planet? Okay, So how do you answer this question? Let's look. So this here is the solution to the answer. So you always write your formula. Oh, I don't know why that line went down there. You always write your formula. Okay? Then you fill in your variables that you know into that formula to get your answer. You must do this for all physics because it's just going to keep your brain organized, right? So your formula for acceleration is here. The numbers you knew, it was traveling at 8.44 meters per second. At the start, when it hit the ground, it was 0, obviously, or the foot. It was 0. Okay, so the change is 8.44 meters per second. And the time goes from 0 to 3.42. There is no change. Okay, so you just do your division, and it's showing that it's going at 24.7 meters per second squared. Okay, so you must do it in that format. Please make sure that you do it like this for all your equations moving forward. Write the formula, step 1, supplement your numbers into the formula where they belong, and then give your answer. Very neat, very easy, and very organized, okay? It'll make your life much easier. One more practice question here. So it's about Wile E. Coyote falls off a cliff. His initial velocity is 0 meters per second squared. Again, and he hits the ground at 23.9 meters per second. How much time did it take for him to hit the ground? So for this one, you're going to have to rearrange this problem, okay? So you're not solving for acceleration already. You already have acceleration, okay? So let's look at that. So the formula for acceleration is as follows. So you have acceleration is change in velocity over change in time. Okay, well, that's supposed to be a t. Okay, and we're going to use this, we're going to have to rearrange this to isolate the change in time on the side. So what we're going to do, okay, we're going to times each side by delta t, just like you used to do in math. So times by delta t, okay, times by delta t, okay, and this delta t is going to be over here by itself, okay. So you're going to times each side by delta t. Then I'm going to put this a over here. And how I'm going to do that is I'm going to divide each side by acceleration. Okay? So over acceleration, sorry, this is messy. Over acceleration. Okay? If I was on a whiteboard, this would be a little neater. So our final formula for this is actually time, okay, equals delta v over acceleration. Okay, so we have enough information to solve this question now. So t equals, sorry that this is messy, the Smart Pen does not work very well. Change in velocity, so it will be 23.9 minus 0 over an acceleration here. Okay, sorry about that. And the piece of information we don't have again is acceleration, kind of like the hint I gave you at the start. So we're going to use 9.81. So he's falling straight down. There's no other forces being applied to him other than gravity. So his acceleration is going to be 9.81. So when you go through, when you do time equals 23.9 divided by 9.81, I did it on my calculator, I get 2.436 2 ... Okay, and the answer is, if I go on right here, 2.44 when you round on. Okay, seconds. So this is in seconds. This is how long it should take Wile E. Coyote to hit the ground. Okay, there's another example. Okay, delete this here. My tablet is messing. So you should be able to do up to page. Oh wait. This thing's messing up on me. I'm sorry, guys. There's another example here. I will let you guys go through this one on your own, okay? It's about acceleration again, okay? Another example, remember, this one's actually quite hard, right here. So let's actually look at it here together. Okay guys, so the easiest way for me to explain this, I've tried to explain it a few times here while the video was on pause. The easiest way for me to explain this, well, here I'll clear this, is to give you guys a chart. Okay, so let's say that we have a chart here showing velocity and time. Velocity on the side, or graph, sorry, and time on the bottom. Okay. And obviously zeros here. Okay, what we're going to do here is we're going to realize at point C, which is pointing at this side of the person where he's holding the ball, he's going to have a velocity of 0. Okay, he is going to then, and remember, it's not asking you for the velocity, it's asking you for the acceleration. Okay, so obviously the acceleration is going to be 0 at that point. But the acceleration is obviously also going to be 0 at its highest point because it's going to reach the apex of the height, completely stop before it comes back down. Okay, so at point C and B, it's just going to be simply 0 meters per second squared. Okay, then comes point A and point D. Okay, so from here to here for D and from here to here for point A. It's kind of a complex question because we don't have any information. We don't have how tall this actually is for point D. We don't know how much the thing weighs. We don't know how fast it's going to begin with, but we don't need to. So basically, Raj Beer, I think is how we'll say it, or Raj Burr, or whatever you want to say, is throwing the ball straight up in the air at a certain speed. Obviously, he's applying a force, but the acceleration, okay, that's going to be added on it is going to be negative 9.81 meters per second squared. Why is that? Because the only outside force that's acting on it, well, that we're accumulating, there might be wind and stuff like that acting on it as well, but we're just going to pretend that that's not there. Okay, it's going to start at a velocity, whatever that velocity is. It could be 100 kilometers an hour, it could be throwing it at 10 kilometers an hour. Gravity's going to act on that thing no matter what at negative 9.81 meters per second squared. And it's negative because it's decreasing the speed. Okay, on the way down, the exact opposite's going to happen. Okay, so it's going to start going up at 9.81 meters per second squared. Oh, lag. Okay, so if you have it here, okay, and you have it starting at 0, basically it's going to be going in the negatives till it gets to 9.81 meters per second squared, and then it's going to start going up again. Okay, does that make sense? Okay, well, no, wait, I drew this line wrong. So it's going to start at a certain velocity up here, whatever he threw it at, whatever meters per second he threw it at. Okay, and it's going to start going negative 9.81 meters per second squared. It's going to get to the apex of the height of the thing. It's going to hit 0. Gravity's going to start acting on it and giving it a negative 0.81 meters per second squared for line D. Okay, that's the best way that I thought of that that I could explain that to you. So as velocity is going down, time's going up. Okay, and then you can calculate the changes to get your acceleration after that. Okay, that's just the easiest way I thought of to explain that. Another way of looking at that is the same thing that I just kind of drew. These are 3 graphs showing the differences in motion. So we have uniform motion in this first graph showing that something's traveling at the same speed constantly. So that line's obviously going to be horizontal. If something's increasing speed, obviously it's going to be going up. And if it's decreasing, it's obviously going to be going down. Okay, just another way of looking at it there for you. Okay. Some more examples. So when you have a velocity and a time graph, the slope of this line, so when you calculate for slope, just like we talked about in our last lesson, whether it be positive or negative, is going to be the acceleration of the object. The area under here, so if you do your base times height divided by 2 to get the area underneath the triangle, okay, that's going to be the displacement, because remember we're talking about vectors. That's going to be the change in position, okay, of this. So that's what the graphs look like. Now, There's a whole other lesson that usually takes me about 20 minutes to a half hour to go over with our class about positive and negative acceleration because it's a little bit confusing, more confusing than you would think. But we're going to skip over it just to save time for our at-home lesson. If you want to look into that, feel free to go ahead and look into that. But as long as you know that how to calculate slope, then you can always determine whether it's positive or negative anyway without knowing those rules, okay? So let's move on a bit. Actually, I think this is an excellent spot to end, okay? This video, it's getting a little bit long here. I really tried to take my time on it. You should be able to do up to page 31 in your note packet here now. As it says here, there is extra practice in your textbook here, which you are not obligated to do. Okay, I would like to remind you guys again, I know I keep saying this over and over and over again, we're supposed to be doing 3 hours a week on science. So if you feel like it's taking too long, remember, you do not have to do all of the assigned practice questions. That's what those booklets are what I'd hand out in a normal class. And we go through the practices all as a group. So you do not need to go through every single practice question. If you've got a concept down, you've got it, you understand it, you get all the ins and outs, then feel free to move on to the next page at your own pace. I will never see your practice booklets. There's no marks for it. So just do what you need to do to get by in this situation. I would urge you to read through the questions again. Just read through them, skim them, say, oh, this one's got a ripple in it that I wouldn't have anticipated. Let's see if I can do it. And you might skip 10 or 15 questions and do question 14 out of the book instead of going 1, 2, 3, 4 all the way up to it. Also, there is certain parts that have sections that are extra or hard questions, more difficult sections for it. I'd urge you to go through those ones for sure, okay, to make sure that you're ready to move on. Okay, thanks guys for another awesome lesson. Please feel free to reach out to me if something's not working for you. Take care, guys.